Hey everybody, my name's Aaron. Welcome back to the channel. I recently started this series called E-Waste Wednesday, where I find stuff at e-waste and I bring it back and just kind of take a quick look at it on the channel. Well, in my recent E-Waste Wednesday visit, I found this Mac SE. Well, not this one actually, it's this one back here, but we'll get to that in a minute. Anyway, I thought it would be a quick fix, so I attempted to get it to boot during the E-Waste Wednesday episode, and I did get it to boot, but I found that there were a number of other things wrong with it as well. So today, I'm going to be taking a look at this Macintosh SE. It's coming up right now on the Retro Hack Shack. So the first thing I wanted to do was see if this Mac SE would boot and see if the floppy drive was working. Now, in order to do that, I was going to need some system disks, and I already have a set of system disks, but I just have the one set. And so the first thing I wanted to do was make a duplicate of those so that if for some reason the floppy drive was bad, it wouldn't destroy the only set I have. These disks are hard to make because you need to have a drive that supports the variable speed 800K floppies that the Macintosh used in so many of their machines. So when you're doing that, you just need a Macintosh that supports writing to an 800K variable speed floppy. I just happen to have another Macintosh SE that I knew that was working in my collection, so I pulled that out to see if I could make these floppies for myself.
Come on, guys! I thought you knew better. Don't copy that floppy.
Now, as you may know, I am not an expert in Apple products at all. So for me, I just went to the system manuals to see how they recommended copying a disk. And sure enough, right here it says, here's how to copy a disk. You can put it in, you can take it back out, which leaves the icon, and then you can simply drag that onto a new disk, and that will copy the contents over to that disk. I'm sure there's better programs to use to copy disks. I think there's one called Disk Copy that works really well. But for me, this was the easiest way to get started, and it did allow me to make copies of all my disks. Now, just so I didn't forget what these disks were for, I went ahead and made some reproduction labels. I love doing this. It makes me feel a bit more nostalgic and proud of my work. And so I went ahead and made these, what I think are authentic replicas of the disk labels. And so now I have a nice set that looks like it belongs with this Macintosh SE. Now, before I actually put my new system disk into this Mac SE, I wanted to give the floppy disk drive heads a good clean. So I pulled out my faithful old head cleaner here, put a little alcohol in a couple of places, and inserted that into the drive. And then when the system boots up, it'll try to spin the disk a few times, and that alcohol on the cleaning pad will clean off the heads. After waiting just a minute to let that alcohol, any remaining alcohol dry off those heads, I was able to put in that brand new disk that we made, the systems disk, and sure enough, bada bing, bada boom, we have a working floppy drive and a working Macintosh that boots up at least off a floppy disk. And just to verify, this is System 6.08 as expected, so it looks like everything is working great so far. There are other things that can go wrong with these floppy drives. For example, sometimes the rails need to be lubricated or the insides need to be cleaned. And of course, there is an eject gear that does break down over time, so that may need to be replaced. But it looks like in terms of this machine, all of that is working just fine. Now it's time to turn my attention to the disk drive. I am getting some activity lights on the disk drive, but absolutely no sounds of the disk spinning at all. And that is pretty concerning for me. So the disk drive is located right here on top of the floppy drive. I want to take it out just to do a quick visual inspection and see if anything is going wrong. It would be great to get this drive up and working again and see if there's any files still on it. Getting the disk drive out is fairly simple. First, you just need to remove the SCSI cable and remove the power cable that goes from the analog power board over to the Mac system board itself. Once that's out, there are these screws that are screwed into the back of the floppy drive chassis. Hopefully you can see them here. They're kind of hard to get to, but with a long enough screwdriver, you can reach them and they come out pretty easily. At this point, you should just be able to slide the drive out, the drive chassis. And unfortunately, if you have a microscribe drive like this one, they put the power adapter in kind of a weird place on the side. and you can't really get that out without removing the drive itself from the chassis first. And now I can get my first look at this drive. It's fairly clean on the bottom. This is a Microscribe model 8425S, so it's a 25 megabyte drive, and these were fairly common, I believe, in Macs of this vintage. Now, I thought that this drive might have perhaps a stuck motor or a stuck head, which is fairly common, but upon doing a visual inspection, and thankfully I did this before I jumped the gun here, I did notice this section up here underneath the rail where there was just a bit of an issue, as you can see. So the first thing I wanted to do was remove this controller board here to get a better look at what was going on. And luckily, this is fairly modular. It's just removing a couple of wiring harnesses, and then you can simply slide the board out the back of the drive, giving me a better look at what was actually going on this board. And here we go. It looks like there's maybe potentially a few fried components here. I mean, there's a capacitor that doesn't look too good, and a few resistors that looks like they've been shorted and perhaps fried to a crisp. So I need to get those components out of there. So I turned to my trusty desoldering station here and removed those two resistors, and then I could use the soldering iron to remove that electrolytic capacitor. And here's that middle resistor. You can see it's just been blown to smithereens, and in fact it did break apart in my hand as I was trying to examine it to see if I could find any indications of what the values were for this thing. So I started at the center of the blast radius and kind of worked my way out in terms of troubleshooting these components. And you can see that this tantalum capacitor is measuring about 3 ohms, which is really, really low. Well, this identical one right next to it is measuring up in the mega ohm range. So I think we found our smoking gun. I think we have a bad tantalum capacitor which shorted and then blew out that resistor. So I went ahead and cleaned up the area and looked at everything else and measured everything else, and it looks like everything else in this area is fine except for these 3 components. This PCB is obviously showing its age, but if you're looking for a brand new PCB, look no further than the sponsor of this episode, PCBWay. PCBWay offers inexpensive PCB manufacturing and a whole lot more. Need assembly services? No problem. They can do front side, back side, through-hole components, you name it. They also offer 3D printing, CNC milling, and more. So check out PCBWay for your next project, and I thank them for their support of the Retro Hack Shack. So in order to troubleshoot this further and figure out which resistors I needed to order, I went ahead and pulled out yet another Macintosh SE from my collection. Why in the world do I have so many Macintosh SEs? And I was able to use that as a reference to try to figure out what types of resistors these were and what values I should order in order to replace these components. If I get it right, maybe this drive will actually work. While I wait for the parts to come in, I thought I would go ahead and try some alternative methods to replacing the hard drive altogether with a more modern solution. There's 3 main solutions that I'm aware of for adding emulated hard drives to a Mac like this. One is SCSI to SD, which is a rather expensive board, but it does seem to have a high degree of capability and compatibility. The next is RA-SCSI or raw-SCSI, which has a lot of compatibility, but does get a little bit on the expensive side if you include the cost of the Raspberry Pi. If you already have a Raspberry Pi, then this is a fairly affordable option. Probably the most affordable option is going to be what I'm going to try today, which is the BlueSCSI. The BlueSCSI is a device that utilizes the Blue Pill STM development board, and it attaches to this daughter board and allows you to connect this to a Mac and emulate a drive fairly easily with an SD card. Now, I got mine as a kit, which I will assemble now in fast forward mode, but I would recommend that you actually buy a version that has at least the SMD components already soldered. It's going to be a lot easier for people that maybe are not experts in soldering, especially when it comes to soldering the micro SD slot to the board. That was actually fairly difficult, or it would be, I think, if you didn't have advanced soldering skills. The version that I received came with this nice little getting started page of paper here, which was actually printed on an Image Writer 2. How cool is that? In order to use the BlueSCSI, you're going to have to find or build yourself a hard drive image for a Macintosh, depending on which system you're running on. Now you can find these already pre-configured around the internet. I'll let you do your own searching there, but there are links on the GitHub page to some images that are known to work with this device. Once you have your image, you're going to have to put it on the SD card and you're going to have to name it in a specific fashion, which is detailed on the wiki page on the GitHub site for this particular project, in order for the board to recognize it. But really, once you take a look at the instructions, it's very straightforward, and I would say it's pretty easy to get started with. Well, you know what? It's been a while, and I think it's high time we have another Penny cam. So Penny's 18 months now, and she's calmed down quite a little bit, but we actually took her down to a little beach here that's in our town, and it was low tide, and there's some stairs and a wall behind us, you'll see in a minute. So she can't really like run completely free. She's limited a little bit in scope here. So this was her first time off leash. And as you can see, she's doing really well. She's running a little bit and then coming back to check to make sure it's okay, and then running a little bit more and coming back. So we were really pleased with her behavior of being off leash. And she just had a ball at this little beach, running around and checking everything out. Okay, so I've got the BlueSCSI attached here to the SCSI cable. I just ran that through the expansion slot hole here. I loaded up HDA, a disk image that was suggested by the BlueSCSI project. So I've got that on there. We'll see what that does. And I've got my SD card in. It's formatted correctly. The file's on there. It's named correctly, which is very important. So I'm just going to go for broke here and see if this actually boots off the BlueSCSI. Here we go. Will it boot? I've got a red light on the BlueSCSI. I heard the bong. Oh, look at that. There's no disks in. Welcome to Macintosh. Look at that. It's working. Okay, about the Finder. System 6.08 and Finder 6.18. So that's a 6.08 system. Now this says BlueSCSI Mac Plus, but it's obviously working on the Macintosh SE. There's a System 7 folder, System Picker, System folder. Yeah, it all seems to be working. Cool. So let's try another hard drive image. Okay, this is another image that was built for, I believe, the Mac Plus, but it should work here, and it's supposed to have a lot of games and things like that. Again, this was linked in the Blue Pill, on the Blue Pill GitHub page. Let's see if this actually works. Seems to be working. I think I would have gotten a sad Mac or a question mark. Yep. Okay. Seems to be working. Let's see. Temporarily turn off extensions and restart. I don't know if this is going to work. Extensions off. Okay. Let's see if this works. Hey, there we go. And look at those games. Very cool. Now, of course, the Macintosh was not known for its games, but let's go to I don't know, something around 89. Let's see what's here. Captain Blood. Ooh, Car Wars. Oh, let's play Car Wars. Let's go with a Scout. Yeah. Oh, this is, you got to do 2 players though. That's the problem. How do you play? Oh, there we go. Okay, that's enough of that. If I had 2 players, I'm sure it would be fun. Here's Indiana Jones and the Last Crusade. Let's try this one. Indy. Okay, not bad. It's not great, but it's not bad. Oh, there goes Indiana Jones. Can we skip this? Nope. I'll skip it. There we go. Barnett College, New York, 1938. It's amazing what you can do with black and white graphics in such a small resolution. Ooh. Indy, you're back. Yes, and I have the Cross of Coronado. Not bad. I would have played this. Doesn't really compare to what was out at the PC, on the PC at the time, but if you had a Mac and you wanted to play an adventure game, this looks like it would be pretty good. So yeah, this looks like a pretty fun game. I may play this later on when I have some more time. Here's Crystal Quest. I've heard that this is good, but I've never played it because I didn't have a Mac growing up. Mouse moves your ship around. The mouse button fires. Move your ship, collect the crystals. When you collected them all, the gateway will open and pass through it to the next wave. Ooh, okay. Okay, nice. You gotta collect the crystals. Oh, no. Oh, there it goes. Okay, hey, this is pretty fun. I like this. Oh, there's the gate. Oh! Through the gate. Oh, come on! Okay, I gotta get in this without hitting it. There we go. I like the sounds. Oh, gotta be careful. Game over. Hey, that's a fun one. Number 1, all-time high score list. Shack. There we go, Retro Hack Shack. Almost 40,000. That's a fun game. I'll have to play that some more. Okay, so if you remember, if you watched my E-Waste Wednesday video, well, when I went over this particular Macintosh SE, I found that there was an accelerator card in it. And the accelerator card had a 68,000, which was a 16 megahertz 68,000, which should provide a little bit of a speed bump to this particular machine. So in order to test that, I'm going to run some benchmarks. And what I wanted to do was do a side-by-side comparison. And luckily, since I have several of these SEs, I pulled out this one, which has a stock 68,000, but it has a SCSI to SD card installed inside. So we can do 2 comparisons now with the speedometer benchmark. We can compare the speed of the CPU between these 2 machines, and we can compare the speed of the devices that we're using to emulate the SCSI drives, the SCSI to SD on this side and the BlueSCSI on this side. So I thought it would be interesting to take a look at both of those aspects and just see what they look like, see what the speed improvements are and the speed of the disk emulations are on each of these systems. So the first thing I need to do is I need to make sure that the accelerator card is up and running. It's a fairly rare card, but I did find a version of the manual, RTFM, and a version of the driver, I believe, that should work here. So it's a speed card. So if we open up this folder, I think the only thing that I have to do is, according to the manual, is drag this bin file over to the system startup, or the system folder on the startup disk, which I believe is this one here. So let's just see if that works. I'm just going to drag this over here. So that is here. So I think if I reboot this, it should work, and it should give me a notification when this boots up, whether it's using the speed card or not. So let's just go ahead and try that. Okay, I did not see a speed card notification, and this just says speed card 1.6. So where does this need to be? Okay, so I think I figured out what was going on, and probably a lot of you Mac heads out there, people that grew up with Macs, were shouting at me for what I was trying to do, but never claimed to be a Mac expert. In fact, many times I've said I don't know Macintoshes very well at all. Anyway, it turns out that was a compressed file, that bin file. So I was able to use Stuffit to uncompress it and then put it in the system folder. I did that on the emulator, which wasn't the actual system folder in use. It was just the system folder, just the folder itself. I don't know if there's a difference, if Mac knows like, hey, this is the system folder I'm using right now, so I'll install this as a driver or what. But anyway, I dragged the resulting uncompressed file into the system folder, which should be booting up when I boot up this Mac. So let's see if we get the little description down in the bottom that tells us we're using the speed card. I did not see a speed card message.
I did not see a speed card message.
Drag this file over into... Well, let me do it. Yeah. But that should work. So let's just go ahead and restart. Yeah, there's nothing that... Oh, there it is. Ah, there it is in control panel. There we go. Okay, so now we have the speed card cache is on. I think I'm missing, there's no, this should be the coprocessor. Does it let me turn the coprocessor on? No. So I think I might not have the coprocessor installed. I don't remember when I was looking at the card whether it had the math coprocessor or not, but it's definitely not letting me turn this on. So that's okay. We'll just, we'll deal without that. Okay, now that we have that up and running, let's run the benchmarks on these two machines and see what the difference is. Okay, this is definitely still showing a 68,000, which is okay, but it doesn't say whether it's... Let's see whether it says 16 megahertz anywhere. So let's just run the performance test. I just want to do the performance rating, I think. That one's running. Let's run the one on this side. Okay, and I'll be back in a minute with the results. All right, both of these are done. We can take a look at the numbers, and I assume that the higher the better. But you can see this CPU is right on the money because Mac Classic is saying 1.0, and this is almost 1.0, 0.999. So yeah, this CPU is 2.306, so quite a bit faster, and the disk is also faster. One thing we have to keep in mind is that I formatted the BlueSCSI SD card as exFAT because it said that was faster. I may have formatted this one as FAT32, and that may also impact the numbers slightly for the disk. But at least from what I can tell, the BlueSCSI may be faster, or at least that, like I said, the file or the partition type formatting may be making the difference there. And then in terms of graphics, there's quite a bit of difference here. So the graphics and the math are all at around 1. And then over here, the graphics and the math are at 1.8. So yeah, that looks pretty decisive that accelerator card is definitely helping things out. And I guess this is a consolidated... Oh, I can't... I was trying to move the mouse over. Yeah, that doesn't work. I need to use this mouse. So I guess this is a consolidated score here, this 0.958. Old PR, is that performance results? I don't know. 0.958 versus 1.9. Definitely that accelerator card makes a huge difference, apparently. Hey guys, well look what came in the mail. It's a nice package from my friends over at DigiKey. And so I've got my parts now to hopefully fix this hard drive here. So here's the part that was burnt out and had the damaged components. And I'm pretty sure what happened is, I identified that this is not your ordinary electrolytic type capacitor. It's actually a tantalum, and those are known to blow and cause short circuits. So this tantalum that was here did that. It actually blew, caused a short circuit, which then caused this resistor to blow here. There's another resistor here, which is where? Right here. This resistor has a little bit of damage on it on the outside, but and I thought that perhaps this was damaged as well because it was reading 0.5 ohms. And I thought, oh, well, certainly this couldn't be 0.5 ohms. But actually, I went ahead and measured some of the other similar resistors, these wire wound resistors. Like I measured this one, and this one was like 0.4 or 0.6 ohms. This wire wound resistor, that's hard to say. This wire wound resistor here is a precision resistor. The fact that this has an actual wire that is running around a non-conductive core here, and it's also made with not just with copper, but with the various types of metals that go into that winding. And by the length of the winding, they can really precisely control what the resistance is of these things. And so they're used in kind of a precision way. I mean, you can get down to like 0.01 tolerance on these things. So I went back and I did some more research, and I think that this resistor is actually okay, and it's supposed to be reading at that value. So I'm going to put this resistor back in down here. For this resistor here, though, this pad over here is gone. And so I did some tracing here, and I don't know if this is going to stay in place for me to do this, but I actually, underneath here, it might be hard to see on camera, I can see a trace that's kind of coming over towards this pad, and I can kind of push in where the burn mark has eaten away some of the solder mask. I can kind of push in here and get to that trace, even though the pad is gone. And so I can see that this particular resistor that goes in this position is going to have to be connected right here to this side of this capacitor. Now on this side, it gets a little bit more tricky. There is a pad here, and this should go off to a power rail, I think, at some point. So if I take a look at this pad here, and I go over to the power rails, whoops, this thing's kind of moving around on the screwdriver. If I go over to the power rails, I can see if it is connected to anything, and sure enough, it is connected to one of the power rails here, which I believe this is the, what is that, 12 volt or 5 volt rail? Anyway, it's one of those. And over here, this pad is also still intact, so it's good, but this probably goes over to, yeah, this goes over to ground. So anyway, this pad here is still good, so I can use that. And then this one, I'll just have to connect directly to the this side of the capacitor over here. And of course, there's no telling with this board, even if I fix these components and replace them, there's no guarantee that that is going to make the board or the drive work again, because this particular short here that happened with this tantalum could have affected any of the ICs that are connected there to whatever this rail is. And so, you know, this chip, for example, could have some internal faults or what have you. So I tested everything else. I know the resistors and capacitors, the little surface mount stuff are all good in this area of the board, but these ICs here could have been affected. And if that's the case, then it's all over for this particular drive. I'm not going to go to the trouble of trying to fix those, because it's difficult to troubleshoot, and these drives are notoriously they're on their last legs anyway. They're not going to survive for that long. So if we can't fix it, the best solution is just to use one of the SD to SCSI to SD devices. Now, unfortunately, this tantalum capacitor here doesn't have any clear markings. Like this one obviously has a clear positive marking. These are polarized components after all. So you need to get the positive and negative sides correct. But it does have, upon closer inspection, it has a little bezel on this side. So I'm assuming that that is the positive side. It's usually the case. So I'm going to be putting the positive side over here in the positive direction. And I'm just going to put a little fresh solder on one side of this. And that'll hopefully allow me to tack this down. There we go. It's looking good. I'm going to come back and just put a little bit more on the original side here as well. Okay, it's more than enough. Looking good. All right, so there it is. There's the repair completed, and you can see. Well, I say, here's this part of the repair completed anyway, if it works. And you can see that this particular resistor, I just bent the leg over and soldered it to that same pad that the capacitor's on there. And then everything else is in place, and we can reassemble the drive and see if this works. Okay, the drive is, the board is connected and screwed back into the drive. I'm going to leave this outside the chassis for now. There's no use going to all the trouble of putting it back in the drive carrier, putting, screwing all that stuff in, until I know that it works. Cause like I said, there could be lots of other things wrong with this drive. So for now, I'm just going to leave it like this, and then we'll turn this around and see if we get anything from the drive. Okay, keep your fingers crossed, everybody. Let's see if this works or if something blows up again. The good news is I see the drive spinning, or I can hear it spinning. I can see the motors moving. So what do we get? Hey, look at that. I swear I can hear it. I can hear it. Speed card comes up. Welcome to Mac. Oh my goodness. The drive is working. McLaughlin, whoever this belonged to, obviously must have been McLaughlin. Look at that. The stupid tantalum caps, the bane of many computers' existence. Those stupid things short and cause all kinds of problems. But in this case, look, it's all working. We've got Reader Rabbit, we've got Excel, we've got Playroom. This must have been repurposed maybe as a kid's computer. Let me just zoom in on the screen. We'll take a look at what's on here real quick. And I apologize for any moire effects that might be going on, but hopefully you can see this. Let's just take a look and see what version we're running here. 6.05 with Finder 6.15. So this is an older version, a little bit older version of Mac OS. Oh, wow, this is so cool. What should we do? There's PGA Tour. What is PGA Tour? Is that a game? It is. PGA Tour Golf. I wonder how long it's been since this Mac has worked. Obviously, this went bad at some point. Look at that, 1991. Electronic Arts. So obviously this drive went bad at some point, and that was probably the end of it, right? They were like, okay, we're done. Put it in the closet, whatever. And then eventually they took it to e-waste. How can I get by this? What is the yardage for the regular white tee? Oh, copy protection. Got to go to the manual. I'm not going to do that today because this is already, video's been long enough. Let's just pick one and see if we get it right. Number 4, let's just say, let's say 289. Well, we can't play that one. But that's pretty cool. Let's open up Word and see. I won't share any personal details, but let's just see see what Microsoft Word looks like. Maybe open a document or two just to get a feel for what was going on at this time. So here's Word. Oh, nice. Look at this. Megan's Christmas list. Here we go. Game Boy Tetris, Game Boy Mario Land, Game Boy Donkey Kong. This is awesome. Obviously, Megan was a gamer here. Camp Barbie Starlight Motorhome. Oh, man. This is awesome. And I love how they use the fonts and italics. Like, they were really into this, these kids. Let's see what else is on here. Oh, a purse. Nice. Mr. Bucket Game. What was that? Bumbleball. Baby Checkup. Lion King Sleeping Bag. This is awesome, man. Oh, my word. Who made a list like this on their Mac for their... These must have been geeky kids, right? Like, I just wrote out my list and gave it to my mom, or circled the stuff in the Sears catalog and said, okay, Mom, I put my name next to everything I want for Christmas in the Sears catalog. That was basically how I did it. But these guys got fancy, man. They put all of their stuff in this list and probably printed it out on their image writer too and handed it to Mom and Dad and said, here you go. Very, very cool. Well, now that this Macintosh SE is fully working, there's just one thing left to do in terms of restoration, and that is to give this thing a good clean. It is a little bit filthy, especially in the corners here, as you can see. There's also this Velcro tape that's left over from, I don't know, maybe a screen protector or glare screen or something that was hanging on the outside. You see this a lot on Macintoshes, so I'm sure it's some sort of standard accessory. But anyway, it's time to take this off. So the first thing I did was I took some 91% IPA and just sprayed that on top of the fabric side here of this Velcro tape and let that sit for a few minutes to really work in and try to dissolve some of that glue. Then I used a pair of pliers and a plastic spludging tool, I think that's what those are called, to both lift up the tape and at the same time use the spludging tool to take as much of the adhesive off the case as possible. There was still a lot of adhesive left on the case itself, so I went down my laundry list of different ways to deal with adhesives. And the first one I started with was just more IPA. Let that soak in and see if that would get the adhesive off. That didn't work, so I pulled out my Rosinol lighter fluid, which is the next thing. I've been using this quite a bit lately, but even this didn't work. So then I tried some Goo Gone, and this seemed to affect the adhesive well enough for me to get most of it off, and then finish up the cleaning with a little bit more isopropyl alcohol. One thing I've learned over the years is that you need to have a number of different solvents and things that can clean up these messes. You can't just rely on one. I get comments in every episode. Did you try this? Did you try this? Sometimes you just have to try some different ones until you find the thing that works best for your particular problem. And you can see the one on the left here is looking pretty good now. There's still some discoloration, and maybe perhaps at some point I'll retrobrite this, but not right now. And really the rest of it was just up to some Windex and some scrubbing. I mean, the Windex really helped clean up the screen, clean up all the gunk out of the corners. I washed each side of this really well, and I even used that little spludger tool to get into the nooks and crannies. You can see here that using that to go back and forth in these little slots, which are all over the Macintosh, really helped get all that gunk out and make it look brand spanking new. Now, one thing I didn't show before is that this Mac came with the interrupt and reset buttons that extend in and press the buttons on the inside of the chassis, but they were oddly bent inwards quite a large degree. So you can see I used a paper clip here to bend those back out a little bit, and I left them sit that way for a few days. And now they're not perfect, but they're much straighter than they used to be. So I just need to clip this in to the right spot, and it's really nice to have this because this often falls off these Macintoshes, and you can get in there with a paper clip and hit those buttons, but it's nice to have this. Really makes the whole thing more complete. Now with this system fully repaired and restored, the only thing left to do is to do one last test to make sure it's still booting up, and yep, it sure is. And now we can just relax and maybe play a few games of Chessmaster before I have to go back and edit this video and get it out for you guys. Well, I'm so glad to see this Macintosh SE up and running exactly as it would have been, close to the time it came out. I'm sure this had some updates over time, maybe to the system software or whatever, but original hard drive, original floppy drive. I mean, I didn't really have to do anything, but it was still fun to take a look at those SCSI to SD devices, especially the BlueSCSI that I tested out. Now, some of the more common problems you would have as opposed to exploding capacitors, which are a problem, let's admit it, would be that as I mentioned in one of my other videos, that the drive head would get stuck on the little rubber bumpers that tend to disintegrate over time. And so the drive head tends to stick to one, and then you can open it up and fix those bumpers, but it's kind of difficult and time consuming to do. The other thing is the heads, especially on these drives, can tend to stick to the heads over time, or the heads stick to the platters over time. And typically what will help with that is when you power on the drive, you can just kind of rock it gently or give it a little knock, and that'll basically free it. You don't want to move the heads manually. because that could easily scratch the surface of the platters inside the disk. So those are a couple of the more common ones that I tend to see, but it was really interesting just to do a visual inspection, and it shows you how important those visual inspections are. The components that I was looking at were kind of underneath some of the mounting hardware, and if I hadn't looked closely, I would have missed that altogether. So doing those visual inspections is very important anytime you go to repair some of this equipment. But I'm super glad to see that the disk is working. We'll see how long it lasts. If it ever does get to the point where it fails completely, we've got the alternatives of using those BlueSCSI or any of the other SCSI to SD devices that we can pop in here. And it would be much quieter. I don't know if you can hear. Oh, what's that? Pyro, screensaver. Cool. I didn't even see that before. Awesome. Sorry. There's quite a bit of noise going on with this, with the actual hard drive, as compared, obviously, to the emulated devices. And that in and of itself may be a reason to use those devices, not to mention the expanded capacity, easier moving files in and out with emulators, etc. If you'd like to see a video about how I moved files onto those SD cards using an emulator, how to get files on and off of those hard drive images, let me know in the comments below. I'm happy to share my experiences. Again, I'm no expert, but I was able to get it done, and I'm happy to share my process with you, so that might help you as well. That's going to just about wrap it up for today. I do want to encourage everyone to subscribe to the channel. I'm trying to hit 10,000 by the end of the calendar year, so about 6 months to go or so at this point, and would really love to get those subscription numbers up. So if you haven't subscribed yet, please do continue to like, and thank you to all my patrons. There will be some after the episode commentary that's available for patrons as soon as the video gets to its normal close. Then for patrons, they'll get that added benefit as well. So thank you for your support. Thanks for tuning into the video today. I really appreciate it, and we'll see you next time. Patrons receive ad-free and early access to content after the episode commentary, and of course, your name in the credits. If you liked that episode, here's a few more you might enjoy, and I thank you for your support.
End of line.